Alright, so now we're going to talk about different forms of expressions and eventually the distributive property, which I'm sure you guys have heard before. But the thing about composition is that there's two types of expressions. There's expressions that are in factored form. Now factored form is a whole expression is just one term. So if it's one term, it just consists of factors, so we call it factored form. And then there's expanded form. The expression has two or more terms. So any expression with two or more terms is called expanded form. So the reason why is that there's actually two types of equations that we can solve. We can solve equations in expanded form and solve equations in factored form. So it's important for us to be able to go back and forth. So these next examples are just now identifying the type of expression it is. So this first example, if we look at the composition of it, there's no plus or minus outside of parentheses. So this is actually just one term. So if it's one term, this expression is in factored form. If we look at the next expression in B, right away we notice that this negative sign is splitting another term. So this actually has two terms, so this is expanded form. And the last expression, if you notice, it's -2 times the parentheses are grouping all of these terms. So this is actually just one term. So this is factored form. So I just wanted to talk about that. So when you hear me saying things like expanded form and factored form, you'll get the idea. So a grouped factor contains more than one term. So if we look at a grouped factor, if we talk about a grouped factor, it's a factor, but it contains more than one term. So just as we looked at up here, we could call the factored form up here, this is actually a grouped factor. It's one factor because of the parentheses, but inside the factor there's three terms. So there's more than one term in that factor. All right. So the distributive property comes from the fundamental property or principle of mathematics of multiplication. So when we talked about multiplication before, that we multiply digit by digit, it's the same as multiplying term by term. So this was actually called the distributive property. The distributive property states that grouped factors must be multiplied term by term. So it's basically talking about the groups and grouping things. If I have 5 groups and the group has a 2x term and a -3 term, then I need to group 5 of each kind. So I'm going to apply the distributive property here. So we notice this expression has a grouped factor. This is in factored form. It's one term. This is a group factor. So again, this is just one term. It's in factored form. If I want to multiply, this is 5 times this quantity. I need to multiply to each term. So this term, 5, gets multiplied by the first term, and it also needs to multiply the second term. What's going to happen is we're going to actually get two separate terms then. So the first term, we're going to take 5 and multiply it by the 2x. So this just becomes a new term, and the new term is 10x. We could just multiply the factors together. But it also generates another term where I have the 5, and then I multiply it by -3, and 5 times -3 would be -15. So when I multiplied, I had to distribute term by term, and you notice when I was done, I got two terms, or expanded form, right? All right, let's apply the distributive property to this one. And again, how do we recognize it? Well, I'll have this grouped factor. So this is just one term, and inside this factor there's actually 3 separate terms. So the other factor is -1. So again, that negative is on the outside. So if I'm going to multiply this, I have to multiply the negative 1 to every term in that factor. So it would be a negative 1 times the 3x. So this would be a negative 3x term. Then I need to distribute negative 1 to negative 2y. So that would be negative 1 and then times negative 2y. So that would be a positive 2y. And then finally, the last term, I need to distribute the negative 1 to the negative 7. And that would give me a positive 8, or excuse me, positive 7. Sorry, when I multiply. So the distributive property allows us to change the composition of a single term. Basically, this is a term that's in factored form to expanded form. So we start out with an expression, one term that's factored form. In both of these situations, this is one term in factored form. And we end up with an expression that's expanded. So this is expanded into 2 terms. This one is expanded into 3. All right, so now that we know how to expand expressions, we can simplify algebraic expressions. So to simplify an algebraic expression, we want to expand any terms containing group factors. So we want to distribute term by term, then combine like terms. So we're basically taking it apart, separating it and taking it apart, or expanding it. So when we do this first example, if I want to simplify this expression, first of all, I need to notice that the expression is 2 terms. I have a 7, and then I have this negative 5 times 2x minus 3. Well, the term on the right has a grouped factor. So in order for me to simplify this, I need to expand this term, which means I need to take this negative 5 and distribute to each of the terms here. Now that's going to create 2 separate terms. It's going to be negative 5 times 2x, which is, and I'll just write it, negative 5 times 2x. And then the next term is going to have negative 5 times negative 3. So what are my term values? Well, I have the 7 from before. Negative 5 times 2x is negative 10x. That would be a new term. Negative 5 times negative 3 is positive 15. So now I've expanded, and I ended up with now 3 terms, and I can combine like terms. I got a negative 10x, that's the only x term. 7 and 15 is 22. So that would be the expression simplified. So let's do this for the next 2. Again, before I do this, I realize that this expression has 2 terms. The first term has a grouped factor, so I will distribute to each of those terms, and I'm going to create 2 separate terms. 2 times x is 2x, and 2 times 3 is plus 6. So now I've just expanded. Now I need to do the same thing to the right, because the term on the right is also a grouped factor. Well, what am I distributing? And I'm distributing a factor of negative 1. So the negative sign is in front of the parentheses. When I do this, I'm going to expand these 2 terms. Negative 1 times x is negative x. Negative 1 times negative 5 is positive 5. So now I have 4 separate terms, and if I combine like terms, the 2x and negative x is x, 6 and 5 is 11. So that would be my simplified expression. Right? And again, it doesn't matter how big the expression is, or the expressions. The first thing I do is look at the composition, and this expression again is just 2 terms. So for each of the terms, I notice I have a group factor. So for the first one, I'm going to expand. I'm going to take negative 3 and multiply it to each of the terms. And that's going to create 3 new terms. So negative 3 times x squared would be negative 3x squared. Negative 3 times negative 2x would be a positive 6x. and then negative 3 times 5 is negative 15. So the term on the right, I can do the same thing because it's a grouped factor. So now I can take this factor of 2 and distribute to each term, and that's going to again create 3 more terms. 2 times 2x squared is 4x squared, positive. 2 times 3x is 6x, and then 2 times negative 1 is negative 2. So I end up with 6 terms now that are all separated, all expanded, and we can combine like terms. I have a negative 3x squared and a 4x squared. That would just be a 1x squared or x squared. I have a positive 6x and a positive 6x. We can put those together to get a positive 12x. And negative 15 and negative 2 is negative 17. So we expanded our original expression and then combine like terms, and we get a simplified expression